Okay, welcome back. We're going to head and work a math stair problem from start to finish. I just want to highlight what we're doing here. We're going to go ahead and solve for the number of steps like we did last time. So we're going to figure out how many steps are here, like 1, 2, 3, 4, 5. The next thing we're going to solve for is the height of each one of these steps. So the distance from here to here on each one of those steps. That's called the unit rise, but we're going to calculate that. The next thing we're going to go ahead and computate is the total run. That is the distance from here. We're actually going to go a little bit past, and we're going to go to about here. And I'll explain that real quick. Because typically a set of stairs has a board that actually ends right there. So a lot of times, not every time, but depending on the design of your stairs, it's not uncommon to have the set of stairs end out here. So when we do this, when we figure out our total run, we're actually going to figure the distance from here out to here. Okay? And the last thing that we're going to solve for is the stringer length. And we're going to solve for that because that's going to be the distance from here out to here. Now again, just like before, it's not uncommon for the stringer to be up here and all the way down here, depending on the design of the stairs. So the length of the stringer we're going to actually solve for accounts for the fact that some stairs have that little extra bit into them, depending on whether you do an open or a closed set of stairs. So the stringer length we're solving for is going to be the one of the bigger one, because we know that will work every time. Okay, without further ado, let's do it. Let's take this problem right here. We'll use the example for a total rise of 102.5. Again, total rise is nothing more than finished floor height measured from the bottom to the finished floor height measured to the top elevation on where your set of stairs are going. So make sure you measure directly vertically. Don't ever measure at an angle. Be very careful of that because you want to be as accurate as possible whenever you figure out your total rise. But in this case, it's 102.5. We're going to head and solve the math by taking that 102.5. We're going to divide by 7. And that's going to give us 14.64286. That's all more we need because we're going to actually round that number. That number rounds to a whole number of 15. So in this set of stairs, we have 15 steps total. Now in the actual stringer, there's going to be one less because if you look at this picture again, I'll show you the reason. So this one has 5 steps total. 1, 2, 3, 4, and 5. But the one is the actual last step is the step on to where you're going. So typically the actual stringer only actually has 4. 1, 2, 3, and 4. So just something to take note of. So back to here. So in this case, the stringer had the total number of steps had 15, but in the actual stringer there'll be 14. Again, it's just one less. So let's go ahead and solve for the unit rise. That will be the total rise of 102.5 divided by the 15, which was this 15. And we get 6.83333. That's in decimal form, but that is what we call the height of the unit rise. And so the actual step is 6.83333 tall. All right. Oh, got a little typo here. This shouldn't be here. But nonetheless, we're going to go ahead and step 4. We're going to convert that 6.83333 we're going to go ahead and convert that into a measurement. What we do is we just simply take the remainder and we take that times 16. So 0.83333 times 16, and that answer is 13.333, and so on. But we're just going to round that again to 13, and we're going to say, and we're going to put it over 16. So the actual answer to this one right here is 6. And we're going to use this 13, and we're going to put it 13 over 16 inches. So that is this number here, the 6.833333 in measurement form. And that's 6 13/16. Okay, let's move on. Step 5, what we're going to do is find the total run. Again, that's the distance the stairs come out this way. And we know they come out 15 times. No, that's not a very good 15. 15 times. We'll do it here. And we're going to take that times 11 because the 11 was the target. The smallest you can go is 10 if you have a nosing, but typically you want to be at around 11. You can actually go bigger. There's no restriction on how big they can be, but for a normal house, as close to 11 as you can get is realistic. So in this case, 15 times 11 is 165. You can change this depending on your needs. So you got 165 as an answer, but if there's not enough room, you can actually shrink or grow your unit rise to make this change a little bit. So you have a little freedom. So you could say, 15 times 10.5 inches and figure out what that is. So there is some freedom. You're not fixed at 11. So if you need to adjust this here, then this will adjust with it, okay, so that it's corresponding. All right. So the total run is going to be 165. All right, the last thing we got to do is figure out the stringer length. Again, the reason we need to do this is because we got to be able to order the material. The formula is nothing more than what we call the Pythagorean theory. And it's something we just have to allow the calculator to perform for us. The two buttons that we're going to use in a calculator look like this, x squared. Oops. Let me draw that again. X squared. And the other one looks like this, square root. So those are the two buttons you're going to make sure you know that where they're at in your calculator before we perform this. But we're simply going to plug in our numbers from above. So we had 165 here as an answer. So we'll plug that in here. 165 squared plus, I believe it was 102.5 squared equals the square root of c. So now you just simply enter that in your calculator. You're going to hit 165 squared. Hit the plus sign. Hit 102.5 squared button. Then make sure you hit the equals button, because a lot of people tend to forget this, but if you don't hit the equals button, it won't work. And then once you get the answer, you hit the square root button after you hit the equal button. So you hit the square root button, and it will give you an answer, and the answer should be 194.2453. So if I go to Lowe's, I know I need to buy a board that's at least 194 inches. Actually, at least 195 inches to get the length of this board correct. So that's how you do it. And that's going to actually be a little bit over a 16-foot board. You're going to need like 18-foot board to do this. So you gotta have to round up to the longest board that will work. So since that's a 16-foot couple-inch board, you're going to need to get an 18. All right, so that's how we do it. These are the steps involved in calculating a stringer. Wish you luck, and have a good day.